Okay, today's lesson 1.14 is a review of our real numbers and classifying numbers as rational, irrational, comparing them and ordering them from least to greatest. So we're going to tell whether the numbers are rational or irrational. So 1/5 is a rational number. It fits the definition of rational number because it is already written as a ratio of two integers. Okay, same for 1/9. Even if we simplify it, it would be a repeating decimal, and all rational numbers are either terminating or repeating. The square root of 22, however, is irrational. If we try to simplify it, we cannot find any perfect square factors of 22. In fact, the factors are 1 times 22 and 2 times 11, so there's no further simplification that we could do. And you can't write it as an integer or ratio. Sorry, you can't write it as a ratio of two integers. You know, no matter what you did, it would be a non-terminating, non-repeating decimal. So let's compare these two numbers. Okay, in looking at these two numbers, one thing we can do is kind of draw out a number line. And just a portion of the number line is needed, and so forth. Let's see. Okay, so if I'm going to look for the square root of 5, I'm going to find it somewhere between the square root of 3. That's not what I meant to write. Somewhere between the square root of 4 and square root of 5, and then you'll have all these numbers, right? But really the one that matters is ... the square root of 9, because this will be 2 on the number line, this will be 3, and this is going to be somewhere between. Okay, so we have the square root of 5, and we're not sure exactly where, but we think it's going to be somewhere on the number line around there. But obviously we can't pinpoint it to exactly graph it on the number line because it never terminates, never repeats, and there's never going to be a place for it. 11 over 4, however, is a rational number, so square root of 5 is irrational, and if we divide 11 by 4, we'll get 2 3/4. So right here becomes 11 over 4 for sure. So you might want to check on those irrational numbers. You can do a decimal approximation. So if you put the square root of 5 in your calculator and hit the square root button, you're going to decimally approximate it to 2.24. Okay? And it's good to put approximately because it's not equal exactly to that. This does equal 2.75. Therefore, the 11 over 4 is greater. Last thing we're going to do is go ahead and put the numbers in order from least to greatest. So if we draw a number line, and then one thing you could do would be to decimally approximate the irrational numbers. So this would approximately be equal to a negative 1.73. The square root of 7, decimally approximately to 2.65. 21 over 8 is exactly 2.625, and the negative 9/5 is a negative 1.8. So then if you graph them on the number line, you can help to see where they go. So let's say the first one's about right here. 2.65. Wow, 2.625 is going to be just a little on the inside of that. And then the negative 1.8. Right there. So least to greatest would be the negative, and put it back in the original form. Okay.